Good day. I am Lance Leonardo M. Walter. I am an ID 123, and I'll be teaching CALENG1 quiz number 2. Today, the topics that we'll be talking about is the derivatives of your exponential and your logarithmic functions. Okay, so before we start anything, I first want to clarify some of the properties of your logarithmic function. So I won't discuss this, but in case you need to go back to these, well, they're all just going to be here. You can just go back. Now, for some important reminders, I highly suggest that you first study your power, product, quotient, and chain rule because we're going to use most, if not all, of these concepts in our upcoming solutions for our problems. Okay, so let's begin. So our first lesson is going to be on your exponential functions. Now, when it comes to your exponential functions, there's two cases. The first one being if your base is e, and the second one being if your base is b, which is just equivalent to just any number. So b is just simply any number. And this is what it looks like. So let's start with the second case, if it's equal to b or any number. So y is equal to b raised to f of x. This is what your function is going to look like, where b is the base or just any number, and f of x is going to be your function or a function of x. It can be a polynomial, a trigonometric, or it can even be another exponential function. It depends on what you're given. So in order to get the derivative of something like this, y prime, is just equal to the derivative of that exponential function right here, or whatever is on top of here. Then we just copy it. We just copy our function again, or just our original function, and then we multiply it by ln of your base, which is just the base here. Okay, now let's have an example. Let's have an example here. So let's say you have your task to get the derivative of 2x squared plus 2x. So first, what you would do is you would get the derivative of this exponent right here. And what is that just equal to? That's just equal to 4x plus 2, right? Then we just copy our original function, so x squared plus 2x here. And then we just multiply it by the ln of the base, which is just 2. This is our base. We just get the ln of that. Okay? Now we have this one. This is our answer. Now let's have a problem. Problem 1. Let's have a practice problem. Okay, we don't want any problems. Okay, so let me see here. We can try doing this. 2 raised to x squared minus 1 times your x squared. Let's get the derivative of this. Now, right off the bat, you can already see that we have to do our product rule, right? So as I mentioned, I'm not going to explain how you do that. So let's get right to it. So first, let's look at our first term here. 2 raised to x squared minus 1. Well, let's focus on getting the derivative of this first, because this is what we're new to, okay? So first, we get the derivative of the exponent here, which is just x squared minus 1. Let's get the derivative of that, 2x. Then we copy our function, 2 raised to x squared minus 1, and then don't forget to get the ln of your base, which is just also equal to 2. Now, let's put this back to our original solution. So 2x times 2 raised to x squared minus 1 times ln of 2. Now remember, we're getting the derivative of this whole function. So remember, you have to add x squared here. So then we just add. Now the second part of your derivative, where we get the derivative of this one, which is just 2x, and then we copy this function here. So 2 raised to x squared minus 1. So let's just simplify everything. So this is 3x squared 2 raised to x squared minus 1 times ln of 2 plus 2x times 2 raised to x squared minus 1. Now, what do you notice about, that's not 3, that is 2x cubed, my bad. Now, what do you notice about 2 raised to x squared minus 1? Now, we can write 2 raised to x squared minus 1 as 2 raised to x squared of 2 times 2 raised to negative 1. Because remember, if you have something like this, right, b raised to a plus, a plus c, this would just be equal to b raised to a times b raised to c. Okay, so that's how we got that. Now, let's apply this. So 2x cubed 2 raised to x squared times 2 raised to negative 1 times ln of 2 plus 2x times 2 raised to, butterfingers, 2 raised to x squared times 2 raised to negative 1. Now, what do you notice about 2 times 2 raised to negative 1? Now, this is just going to be equal to 1 because 2 times 2 raised to negative 1 is 2 times 1/2, and that's just equal to 1, okay? So with this, we just cancel these terms out, and you will have 2 raised to x squared, and then you have an x cubed here, ln of 2 plus x2 plus x2 raised to x squared, just x squared, not x squared minus 1. X times 2 raised to x squared. So let me just double check. Okay, so this is going to be our final answer. Okay, if you're confused, just feel free to go back to the examples. So the next exponential function, what if it's just y is equal to e raised to x? So, y is equal to e raised to f of x. Now, for a case like this, it's actually much simpler than if it was a base because our derivative, just like our exponential, is just a derivative of our exponent, e raised to f of x, but no more ln. Now, why is it that there's no more ln? Because remember, we get ln of e, right? If we're applying the same concept as the previous one. However, ln of e is just times 1, so we can just disregard that. Okay? Now, let's have an example. Let's say you want to get the derivative of e raised to x cubed plus 2x squared plus 3x. Well, this is simply just getting the derivative of your exponent, which is just 3x squared plus 4x plus 3 multiplied by e raised to x cubed plus 2x squared plus 3x. Okay, and that's it. Please don't make this mistake. Plus 4x plus 3 times e raised to x cubed plus 2x squared plus 3x. Don't commit this mistake because what's the difference between this one and this one? Well, for this one, we're just multiplying 3 by this one. But what about all these other ones? Well, that's when it becomes wrong. So remember, you have to multiply it by the whole derivative. Multiply it by this whole derivative and by the whole original function, okay? So try not to get confused with that. Okay, now let's do a practice problem. Problem 1. Now, let's say we want to get the derivative of 2x raised to 2x plus 1 minus e raised to 2x plus 1. So once again, we have another one of those product rules here in the first one. So let's get the derivative of that one first. Well, let's first get the derivative of 2x. And 2x is just 2 e raised to 2x plus 1 there. And then we get the derivative of the next one here, e raised to 2x plus 1. Now that should just be equal to 2 times 2x times e raised to 2x plus 1. okay? This 2 right here came from the derivative of this one, okay? So let's just put that back now in our parent function. So 2 e raised to 2x plus 1 plus 4x. Okay, so I just multiplied the 2 times 2x times e raised to 2x plus 1. Now we just get the derivative of this one, which is just going to be negative 2 e raised to 2x plus 1. Because remember, we just get the derivative of this one, and that will just be equal to 2. Okay, that's just a derivative. So then, minus 2 e raised to 2x plus 1. And then we can just cancel these factors out, and we will have an answer of 4x e raised to 2x plus 1. And that's our final answer. Now you might get something more complicated. It's just unfortunate that I can't give anything more complicated because of the time constraint. Okay, so let's move on to the next bulk of our lesson, which is going to be your logarithmic. Logarithmic. I'm sorry if that's wrong spelling, but okay. So just like your exponential, there are two cases. The first one being if it's just a typical log. The next one is if it's ln. Okay? So in exponential, we had any base, right? And then for logarithmic, we just have log. And then for exponential, we have e. For logarithmic, we have ln. Okay? So let's start with y is equal to logarithm of your base. Remember, you have a base times your f of x. So this is the basic form of a logarithmic function, right? Now, in order to get the derivative, your y prime is simply just equal to the derivative of your inside function here all over just your inside function once again. So you just copy it. Then multiplied by 1 all over ln of the base. Okay, and our base here is the base of the logarithm. Now don't forget, if you have something like log times f of x and there's nothing that's written, that's just equal to 10. Okay, don't forget that. Now, let's have an example. Let's say we want to get the logarithm base 3 of x squared minus 1. Now, how will you do that? Well, first, we get the derivative of whatever's inside, which is just 2x. Then, we copy x squared minus 1. We just copy the parent function, and then 1 all over ln of 3. Your 3 here is just your base. Okay? So that's a very simple problem. Now let's go to something a bit more complicated. Problem 1, once again. So let's get the derivative of log base 3 of x squared plus 2x all over x squared minus x. Now, you can go directly getting the derivative of this function. However, the problem is you can further simplify it. And how do you do that? Well, you can see that you can just factor out the x here. So that will just be log base 3 of, I'm going to do a shortcut, so it'll just be x plus 2 times x minus 1. So this is now going to be our function. Now, remember, you must first get the derivative of the inside function here. Now, how do you do that? Well, let's first get the derivative. So I'm going to just write a little barrier here. So x plus 2 all over x minus 1. The derivative of this, okay, we're going to have to apply your quotient rule, okay? So the derivative of the first one, of the numerator, is 1. Then you multiply by your denominator, minus the derivative of your denominator, which is 1, and then you copy your numerator, and then this one all over x minus 1 squared. Then this, if you copy all of it, your x will cancel, and then you have a minus 1 here, and then you'll have minus 2 here, and that will just be -3. So sorry for being quick, but there we go. So we have x minus 1 quantity squared, -3 all over x minus 1 quantity squared. But remember, that answer that we got here is the derivative of whatever's inside there. So this is not our final answer. So remember, so -3 over x minus 1 quantity squared. We still have to divide this whole thing by your parent function, which is x plus 2 all over x minus 1. Okay? And this will just be equivalent to -3 times x minus 1 quantity squared times x minus 1 all over x plus 2. There, x minus 1 here cancels out, and then you will have -3 all over x minus 1 times x plus 2. Oh, and we forgot something, right? We forgot something because remember, we still have to multiply this whole thing by the ln of your base. Okay, so don't forget that. Okay, I almost did. But yeah, this is going to be our answer. Okay. Final answer. Okay. Now, let's move on to the second part of your logarithmic functions, which is going to be your ln, or your natural logarithm functions. So, y is equal to ln of your f of x. So this is just the basic. Remember that ln is basically just log of e, okay? So ln f of x. So how do you get the derivative? Now, just like your exponential, this is going to be more simple than your typical logarithm, because this is just going to be equal to the derivative of your inside all over the original. Okay, there's no more 1 all over ln of the base. If we get 1 all over ln of the base, our base is e, right? Log of e. So that's just equal to 1. That's why we don't have that. So this is going to be our function. So let's have an example. Let's say ln of x cubed minus x squared plus 1. Now you just have to get the derivative of the inside, right? Just like your logarithmic function. You will just get 3x squared minus 2x. And then you just have to copy the original function. And this is your final answer. So remember, this one is the derivative of this one, and this one, you just copy this one. Okay, now let's go straight to a pretty complicated problem. I expect that you're quite used to this already, or at least quite a bit used to this from the previous one, the logarithm. So let's say you have something like this. Ln of x squared plus 1. Now, at first, it might look impossible, right? But let's try to calm down for a bit. Okay, let's calm down for something like this. Okay, let's go back to our definition. It's going to be the derivative of the inside. So remember, this is our outside ln. Now, this outside ln, the derivative of this outside ln is just the derivative of this inside ln all over this ln function. Now, let me show you what I mean. But before anything else, let's get the derivative of the inside, like we always do. Well, this is just going to be 2x all over your, so remember, oh, wait, I forgot to mention, if we're going to get the derivative of this, remember it's a derivative of this inside function here all over this one. So this, what we have here, is the derivative of this one, of this ln. Now, remember, so now we have the derivative of the whole thing. This red square right here. This is the derivative of the whole thing, right? So 2x all over x squared plus 1 all over. This is where it gets tricky because what do you divide this derivative by? Is it x squared plus 1 only, or is it the whole thing? I'll give you a minute to think. So if you said that, sorry, that was not a minute, but but if you said that this thing right here, if that's what you said, then you are correct. Because remember, this is our outside lawn. We get the derivative of the inside, right? Which is 2x all over x squared plus 1. And then we just copy it by the inside. So that will just be ln of x squared plus 1. And we can further simplify this. 2x all over x squared plus 1 times 1 all over ln of x squared plus 1. Okay, so this is our final answer. Okay? Now, just for a bit of practice that you can do, but I won't solve this anymore. You can just try doing this yourself. Ln of 2 raised to x plus 1 times x. Remember, you're going to do product rule here, and you're just going to apply. Don't worry, this isn't too hard. So your answer here is ln of 2 plus 1 all over x. So try to do this in your own time. So I'm giving you a bit of homework so you can practice, okay? So yeah, that's it. So yeah, with that, I would like to thank you so much for watching. I really hope that you learned something. And don't worry, I'm going to send this notes so that you can just go back to it. Okay, I'm going to send this file. And if ever you need tutorials, well, you may also avail syntax tutorials by scanning the QR code flashed on your screen. So just scan this if ever you need help. And you can also book me. So once again, this is Lance Leonardo and Walter from Syntax, paving your way to excellence.